Welcome to True Projects. In this video, we are going to explain about the project that is an intelligent and explainable SaaS based intrusion detection system for resource constrained IoMT. Before getting into the execution, first let us understand what is the project about. You know how everything these days seems to be smart, like smartwatches, fitness trackers, and even smart home devices. Well, IoMT, that is Internet of Medical Things, they are like that only, but they are used in the healthcare. Think of it as a network of medical gadgets. So they are the network of medical gadgets like sensors, monitors, and devices that doctor use that are connected and constantly they share the information. This connection makes it super easy for doctors to keep track of patients even remotely and for the patients to get better care without always having to go to the hospital. It is a game changer, especially for people who need continuous monitoring, like those with the chronic conditions. But here the problem is just like anything connected to the internet, these systems they are also vulnerable to cyber attacks. Imagine someone hacking into these devices and stealing sensitive patient data or even messing with the critical medical equipment. Scary, right? Attacks like ransomware can lock up hospital systems until they pay a ransom, or something like DDoS attack could completely shut down the network, delaying life-saving treatments. These risks don't just mess up the tech, they also mess with the people's trust in the healthcare systems. So while IoMT is incredible for innovation, it is also a big target for cyber threats, which is why securing these systems is such a massive deal. Even though we have lot of methods for detecting this IoMT that has been done to secure IoMT systems, there are still some big challenges, big gaps. We might have heard about ideas that is intrusion detection system. They are basically like security guards for the network, trying to spot anything suspicious. The thing is, there are two main types. One is signature based, and the other one is anomaly based. Now, signature based ideas, that is intrusion detection system, is like a guard who can only recognize the criminals if they have seen their mugshot before. If a hacker comes up with a completely new trick or attack that the system hasn't seen, it just won't catch it. On the other hand, anomaly based systems are like guard who is suspicious of anything out of the ordinary. Sounds good, right? But the problem is these systems often overreact. They flag harmless things as threats, which is constantly yelling wolf when there is no real danger. So we have got these things, these systems in place. They are not perfect. Some threads slip through and some they are rise too many false alarms, making it hard for security teams to focus on actual issues. And it is clear that we need smarter and more reliable way to secure these IoMT networks. So, the proposed system is designed to create a smart and easy to understand intrusion detection system specifically for IoMT, that is Internet of Medical Things, which is basically a network of medical devices connected through the internet. Now, it makes ideas work well. It is structured into three main steps. So, to work well, ideas work well, we have designed three stages where we do pre processing, feature engineering, and classification. In the first phase, we will be doing pre processing, where the system focuses on cleaning up the data. This means getting rid of any irrelevant or noisy information and making sure it is important, it is in a format that machine learning algorithms can use it effectively. Once the data is prepared, then we move on to feature engineering part where we use particle swarm optimization. This helps us to pick up the most important pieces of the data. It is kind of like sorting through a bunch of puzzle pieces to find out the ones that will complete the picture. By selecting the best features, the system becomes more accurate and reliable. Finally, the classification stage comes in. So, here multiple machine learning models are used to analyze the data and detect any intrusions. Here, models like logistic regression, support vector machine, decision trees, random forest, k nearest neighbor, and extreme learning machine are all trained to recognize suspicious patterns, helping to catch any potential security threats in IoMT. And to make the system even more trustworthy and reliable, we have incorporated a concept called explainable intelligence, that is explainable artificial intelligence. Now when we use machine learning models, they can sometimes feel like black box. They can make decisions, but it is hard to understand why they make those decisions. That's where xai comes in. So we have chosen a specific method called shap, that is Shapley additive explanation. So this helps to explain how different pieces of the data contribute to the system's decision making. Basically, this SHAP helps to show which features, that is data points, are most important when the system identifies a threat. It gives us insights into how the model works. It is not just telling us that this is the threat, but it is also explaining why it came to that conclusion. So, this transparency is really useful for administrators and security analysts instead of blindly trusting the system. They can now see and understand the reason behind the system's decisions. This helps them to make more informed actions when an anomaly is detected, improving the overall security response. So, this is the proposed system. And to further improve the accuracy of this project, as an extension, we are incorporating ensemble model, that is voting classifier. Essentially, this method brings together the predictions from multiple models, multiple individual models, kind of like gathering opinions from a group of experts to make a final decision. Each model in the ensemble might have its own strengths. So, by combining them, we get a more accurate and robust prediction about whether there is an intrusion or not. It is like asking different people for their input to make a more informed and reliable choice. And on top of that, we have also built front end using Flask framework. So this means we have created a user-friendly interface where people can test the system interactively. The front end also includes user authentication mechanism, that is secure user authentication mechanism, ensuring that only authorized users can access it. This setup not only makes it easier for users to interact with the system but also lets them to evaluate its performance. And coming to the implementation part, to implement this project, we have followed the steps mentioned in the flow of work. So first, what do we do is we begin by importing all the necessary libraries and tools needed for the project, such as Pandas, NumPy, and Scikit-learn for data processing and machine learning. Then comes exploratory data analysis. So here, the first thing we do is we load the data and explore the data set to understand its structure, features, identify missing values, and gain overall sense of the data we are working with. So here we are using the data that is WUSTL EHMS 2020 binary data, where we will be having only two classes whether there is attack or not. And then the next step is data processing. So here we check for any duplicates and duplicate entries in the data set to avoid skewness and the results, to avoid skewness in the results. So we will be removing these duplicates. Then comes drop cleaning. So this step involves handling missing values or irrelevant data by removing unnecessary rows or columns. Normalizer. So the data set is scaled using normalization to ensure that all the features are on similar scale, which helps to improve the model performance. Then comes visualization part. So here we use various charts and graphs to visually explore the data, helping us to identify patterns, correlations, and outliers that could impact our model. Then comes label encoder. So categorical data is converted into numerical labels using label encoding so that machine learning algorithms can understand and work with the data. Coming to feature selection. So the particle swarm optimization, that is PSO algorithm, is applied to select the most relevant features, improving the model performance by removing irrelevant ones. Then comes data splitting, where we divide the data into train and test. So we use training set for training the models and testing set, that is validation set for evaluating the model on unseen data. Then we initiate all the machine learning models that are logistic regression, decision tree, support vector machine, etc. We will be structuring them. After that, we will be training them with the training set of the data. So training data set is used to train the models so that they can learn the patterns and relationship in the data. Then we evaluate all of them using accuracy, precision, recall, and FN score, and we compare through them graphs. Then comes the part of front end. So the front end interface is built using Flask, which allows users to interact with the system, and it also includes registration and login functionalities using SQLite to store user credentials securely. And in the front end users, they will be able to give feature values related to the intrusion, and that will be pre-processed at the backend. It will be fed with the train model. Finally, outcome will be displayed through the front end of the application where we will have the prediction. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used in this project. So we have used logistic regression, ELM, KNN, that is K nearest neighbor, random forest, decision tree, support vector machine, and extension model, voting classifier. So these are all the algorithms trained on the data set to detect the intrusions. And to implement this project, we need basically hardware and software requirements. So hardware are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we're supposed to open the code folder that contains source code file. So let's open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Here in the archive folder, we have the dataset that is used in the project. So this is the dataset that has been used. Let's open it. It's being loaded. Just wait for a while. So this is the dataset that is used in this project. So here are different features. And based on these only, we will be predicting the network intrusion. So these are different features. So total we have many features. So that is why we are using PSO, that is particle swarm optimization, to select the best features. And based on those features only, we will be predicting the intrusion detection. And this is the target variable where we have two classes, that is 0 and 1. 0 refers to no attack and 1 refers to attack. So close this, get back. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the model file. So this model file contains the algorithm information, and this will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases that we will be using in the front end for predicting the network intrusion. And this is the signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here if you observe, current directory is changed to the code folder's path. Now compile app.py file by giving the command python space app.py. Now click on enter. This command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. And here we are supposed to give our credentials, which are username and the password. So I have given my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see inputs, right? So these are the parameter we are supposed to give as the input. Based on that only we will be getting the prediction related to intrusion. The first parameter we have is DST bytes. It refers to the number of bytes sent to the destination in a network, indicating volume of data transferred. Then we have DST jitter. So it measures the variation in time delay, that is latency, for data packets between the source and destination, showing how consistent the network performance is. Coming to DUR. It is the duration of the connection or session, representing how long the activity or data transfer lasts. Coming to trans. So it indicates the type or category of transaction being processed, such as data transfer, communication request, etc. Coming to TOT bytes, it is the total amount of data in bytes transferred during the entire session or communication, providing a complete data traffic measure. SpO2. It is the percentage of oxygen in the blood, indicating respiratory health with typical health values between 95 to 100. Then we have SYS. It is a systolic blood pressure, which measures the pressure in the arteries when the heart contracts and pumps the blood. Heart rate. It is the number of heartbeats per minute, providing insights into cardiovascular health and physical activity levels. Coming to ST, it refers to the status or state which could indicate the current condition, mode, or operational status of a system or device. So this is about the parameters. Now let us enter them. For that, let's open the sample file. So open the sample file. So here are different test cases. So these are different test cases that we will be using now to predict the intrusion detection in IoMT. So let's apply filter to the target column. So here we have two classes. So first let's predict of class 0. So let's try with this case. So copy the destination bytes. So here we have destination bytes are 186 and the next one is DST jitter, that is 2.3195, and duration is 0.013623, and the next one is trans. So that is 1, and TOD bytes are 682. SPO2 is 98. SYS is 135. Heart rate is 71. Slope is 10, that is 0.36. Now click on predict. And let's see whether the application will correctly predict it or not. So the given input, it will be pre-processed at the backend, then train model will be giving us a prediction. So here we got the prediction that there is no attack detected and it is normal. So here we can understand that there is no attack detected and it is normal. So here it is being classified correctly. Now let's try with this case. Click on prediction. So destination bytes are 186. DST jitter is 2.331. Duration is 0.011661. 1 is the trans. 682 are the Todd bytes. 98 is the SPO2. SYS is 134. Heart rate is 74. ST is 0.12. Now click on predict. So here we got the prediction that there is no attack detected and it is normal. So you can observe that it is classifying correctly for the class 0. Now let's check with the class 1. That is, there is an attack. So let's try with this case. So let's try with this case where destination bytes are 186. DST jitter is 44.727. Duration is 0.14409. Trans is 1. Total bytes are 682. SPO2 is 94. SYS is 145. 73 is the heart rate and ST is 0. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is DDoS attack. So here attack is detected and the attack type is DDoS attack. Now let's try with the last case. So this is the case now we will be trying. So click on prediction. Here destination bytes are 186. Destination jitter is 60.7575. Duration is 0.162065. 1 trans. 682 is total bytes. SPO2 is 98. 148 is SYS. 73 is the heart rate. 0.3 is slope. Now click on predict. So here we got the prediction that there is an attack detected and the attack type is DDoS attack. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here this is a sample outcome graph. Here on x-axis we have class label and on y-axis we have count. This shows the distribution of the target class. And this is the correlation matrix. This is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms which are trained. And this is the precision score comparison graph. This is the recall score and this is F1 score. Now click on sign out. So in this way, just by giving inputs to the application, it will predict whether there is an attack or not in the given data. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.